far beyond the reach of human eyes, where silence dominates and storms rage larger than entire continents. A strange phenomenon has begun to capture attention from those who study the skies. On the giant world of Jupiter, something unexpected has appeared, an eerie green flash that defies easy explanation. For decades, Jupiter has been known as a planet of extremes. It is a world of crushing pressure, violent winds, and a swirling atmosphere marked by the Great Red Spot, a storm so large it could swallow Earth whole. Yet even in a place already filled with mysteries, this new optical signal stands out as something truly unusual. A brief, vivid, green glow, appearing and vanishing in an instant, has raised questions that science is still struggling to answer. What makes this phenomenon so puzzling is not only its color, but its behavior. Green light in planetary atmospheres is rare under normal conditions. On Earth, similar glows are usually linked to auroras, light displays created when charged particles from the sun collide with atmospheric gases. But Jupiter is not Earth, and its environment behaves in ways that often challenge familiar logic. The scale is larger, the energy is stronger, and the atmospheric chemistry is far more complex. Some scientists suggest that this green flash may be connected to intense auroral activity at Jupiter's poles. The planet already produces some of the most powerful auroras in the solar system, driven not only by solar wind, but also by its strong magnetic field and the volcanic activity of its moon. These forces combine to create electrical storms of staggering intensity. Yet even within this explanation, the sudden, isolated nature of the green flash remains difficult to fully justify. Others propose a different possibility, that high-energy particles are interacting with unusual compounds in the upper atmosphere, triggering a brief emission of green light on Earth. Oxygen produces green and red auroras under specific conditions. But Jupiter's atmosphere is primarily hydrogen and helium, making the presence of a green signature far less straightforward. If hydrogen-based reactions are producing this glow, it would imply a process not yet fully understood by current planetary science. There is also the question of timing. These flashes do not appear constant. Instead, they seem random, almost like brief signals flickering in and out of existence. This irregularity adds another layer of mystery. Is this a natural atmospheric reaction that has simply gone unnoticed until now, or could it be tied to changes in solar activity, magnetic shifts, or even interactions deeper within the planet's interior? What makes the discovery even more compelling is how it challenges our understanding of observation itself. For years, Jupiter has been studied through telescopes, spacecraft, flybys, and orbital missions, and yet, something so visually striking could still emerge without clear explanation. It is a reminder that even in a well-studied solar system, surprises still wait in the shadows of data. The green flash also forces a broader reflection on how little is truly known about gas giants. Unlike rocky planets, there is no solid surface to anchor assumptions. Everything is fluid, layered, and constantly moving. Storms merge and vanish. Lightning storms stretch across thousands of kilometers, and atmospheric currents circulate in patterns that are still being mapped. In such an environment, even a brief pulse of light could carry significant scientific meaning. A mysterious green flash has been observed in the atmosphere of Jupiter, sparking scientific curiosity and debate. A mysterious green flash has recently been detected in the upper atmosphere of Jupiter, and it has quickly become one of the most intriguing observations in modern planetary science. This unexpected glow appears briefly and then disappears, making it extremely difficult to study in detail. Scientists are still trying to determine whether it is a recurring atmospheric event or a rare and isolated phenomenon. What makes it so unusual is not just its sudden appearance, but its distinct green color, which is not commonly associated with the known visual patterns of Jupiter's atmosphere. The planet is already famous for its powerful storms and energetic auroras, yet this specific flash does not fully match the behavior of either. It has been recorded only a few times, often without warning, leaving researchers with limited data to analyze. Some observations suggest it may originate high in the atmosphere, where charged particles interact with gases under extreme pressure and radiation. However, the exact mechanism remains unclear, and no confirmed explanation has been established. This uncertainty has led to growing interest in continuous monitoring of the planet using advanced telescopes and space missions. Each new detection adds another piece to the puzzle, but also deepens the mystery surrounding this strange, luminous event. Jupiter is already known as a planet of extreme conditions, including massive storms, strong winds, and intense auroras. One of the leading explanations for the strange green flash observed in Jupiter focuses on the planet's intense auroral activity. Jupiter is surrounded by a powerful magnetic field that is far stronger than Earth's, and this field constantly interacts with charged particles from the solar wind. In addition, volcanic activity from its moon Io releases huge amounts of material into space, which becomes ionized and trapped within Jupiter's magnetic environment. When these high-energy particles collide with gases in the upper atmosphere, they create brilliant auroras near the planet's poles. Scientists believe the mysterious green flash could be a rare variation of this process, occurring under specific and temporary conditions that produce green wavelengths of light. On Earth, green auroras are linked to oxygen emissions, but Jupiter's atmosphere is mostly hydrogen and helium, making the process more complex and less understood. If hydrogen compounds or trace elements are involved in unusual energy states, they might briefly emit green light under extreme pressure and radiation. The unpredictable nature of the flash may result from sudden changes in magnetic activity or particle density. However, this explanation is still incomplete, and researchers continue to gather data to confirm whether auroral physics alone can fully account for this rare and striking phenomenon. One leading theory suggests the green flash may be linked to powerful auroral activity caused by solar wind and Jupiter's strong magnetic field. Another possible explanation for the unusual green flash seen in Jupiter involves complex chemical and photochemical reactions occurring in its upper atmosphere. Unlike Earth, Jupiter's atmosphere is dominated by hydrogen and helium, with trace amounts of other compounds, such as methane, ammonia, and water vapor. Under normal conditions, these gases do not produce strong green emissions. However, in extreme environments like Jupiter's upper layers, intense radiation from the sun and the planet's own magnetosphere can break molecular bonds and create highly reactive particles. These fragments may temporarily recombine in unusual ways, releasing energy in the form of visible light. In rare cases, this energy could fall within the green portion of the spectrum, creating the brief flash that has been observed. Another possibility is that unknown trace elements, possibly delivered by micrometeorite impacts or volcanic material from moons like Io, could be present in extremely small quantities and become excited under high-energy condition. Even a tiny concentration of the right element could produce a visible glow if the energy input is strong enough. What makes this idea particularly interesting is that it suggests the flash may not be a large-scale atmospheric event, but instead a small, localized reaction triggered by specific conditions. However, current instruments have not yet been able to directly confirm these chemical pathways, leaving this theory still open and requiring further exploration. Another possibility is that unusual atmospheric chemical reactions are producing brief bursts of green light, though this does not fully match known science. Another important perspective on the mysterious green flash, observed in Jupiter, focuses on the planet's dynamic weather systems and deep atmospheric turbulence. Jupiter is not a calm world. It is a constantly shifting environment where massive storms can last for centuries and powerful jet streams move at incredible speeds. Within these turbulent layers, energy is continuously transferred between different parts of the atmosphere. Scientists suggest that the green flash could be the result of sudden energy releases occurring when storm systems collide or when powerful updrafts push gases into higher, thinner layers of the atmosphere. In such extreme conditions, pressure and temperature changes happen rapidly, creating short-lived luminous effects. Lightning storms on Jupiter are also far more powerful than those on Earth, and it is possible that electrical discharges deep within cloud systems could produce brief bursts of light that escape through openings in the cloud cover. If these flashes pass through specific atmospheric layers, they might scatter in a way that appears green to distant observers. Another idea is that wave activity in the atmosphere, similar to shock waves, could momentarily excite particles and produce visible emission. However, because these events occur deep within a highly complex and opaque atmosphere, direct confirmation remains extremely difficult, leaving this explanation still speculative and under active investigation. The irregular and unpredictable nature of the flashes highlights how much is still unknown about Jupiter's atmosphere and encourages further space research. A further and more speculative explanation for the green flash seen in Jupiter considers the possibility that we are observing a previously unknown interaction between the planet's magnetic environment and high-altitude atmospheric layers. Jupiter possesses an enormous and extremely powerful magnetosphere that extends millions of kilometers into space, creating a complex system of trapped radiation belts and charged particle flows. In certain rare situations, these magnetic fields may undergo sudden realignments or fluctuations, releasing bursts of energy into the upper atmosphere. When this energy interacts with atmospheric gases, it could produce brief optical emissions that differ from standard auroral displays. The green color might emerge from unusual excitation states of hydrogen compounds, or from unknown trace particles that respond differently under extreme magnetic stress. Another intriguing idea is that the flash could be linked to plasma instabilities, where charged particles behave unpredictably and create localized bursts of light energy. These events would be extremely short-lived and difficult to capture with current instruments, explaining why they appear so rare and inconsistent. Some researchers even consider the possibility that the phenomenon represents a new class of atmospheric electromagnetic interaction that has not yet been documented on any other planet. While this idea remains highly theoretical, it highlights how much remains unknown about Jupiter's deep atmospheric and magnetic dynamics, and why continued observation is essential for understanding these rare signals.